This is another example of finding the slope of the tangent line for our polar curve. So we have r equals 2 plus sine 3 theta, and we could plug those into x equals r cosine theta and x equals r sine theta and take the derivative. But I want to use our formula that we've already created. So what we need to do first is just find r prime. We already know sine theta, r, and cosine theta. There's r, and those just stay the same because they're already in terms of theta. So we just need r prime. So what is our r prime? And again, that's dr d theta. And so that would just become 3 cosine of 3 theta. Remember, you got to use chain rule. So it would be cosine 3 theta times 3. Okay. So now we're going to plug it all in. So we end up with 3 cosine of 3 theta sine of theta plus 2 plus, and you can already see, wow, this is a lot, right? So a nicer way to do it is to just plug it in parts. And so what we're going to do is plug theta equals pi over 4 into r and find it. Plug theta equals pi over 4 into r prime and find it. Plug theta in pi over 4 into sine and cosine and find them. And then just plug the values in. So simplify them in parts. So what is r prime of pi over 4? So we get 3 cosine of 3 pi over 4. And so we look at the unit circle, and we see that that gives us negative rad 2 over 2. So this would be negative 3 radical 2 over 2. So now we can plug that into our formula. So dy dx is equal to, and our first thing is r prime. So negative 3 rad 2 over 2, negative 3 rad 2 over 2. And then now we move on to the rest. I just fill them all in. So we need sine theta and cosine theta, right? So sine of pi over 4 is rad 2 over 2. And also cosine of pi over 4 is rad 2 over 2. So we can plug those in. See, it's just a much nicer way of doing it. Just plug it into the parts and then go from there. Now we just need r. So r is 2 plus sine of 3 pi over 4. And that becomes 2 plus, and for sine 3 pi over 2 on the unit circle, you get rad 2 over 2. You can also just plug these in the calculator, and then you already know what to use to plug in. So we end up with 2 plus rad 2 over 2, and 2 plus rad 2 over 2. Okay. Now it's just a matter of simplifying. So the rad 2 is going to make a 2. And so they will cancel one of those, giving us negative 3/2. And that would be the same on the bottom, since both sine and cosine at pi over 4 are the same value. And then we're going to distribute. Oops, this is a minus down here. Very important to make sure everything is transferred correctly. Otherwise, your answer will come out wrong. All right, so this will be distributive, and the 2 will cancel, giving us rad 2. And then the same thing will happen here. The rad 2 and rad 2 will make a 2. They'll cancel one of the 2's, giving us 1/2. And you could take these a lot slower than what I'm doing right now. And so the bottom is just the same thing, but we have a minus in front, so they change signs. Okay. So this would give us negative 3/2 minus plus 1/2 would be negative 1 plus rad 2. And then on the bottom, we get negative 2 minus rad 2. So there is our slope. So the slope of the tangent at theta equals pi over 4 is negative 1 plus rad 2 over negative 2 minus rad 2. And there we go. Now, we can simplify this some more by rationalizing it and do negative 2 minus rad 2 with a plus now to make our conjugate, and simplify it that way and get something a little bit nicer. So if we multiply the top, I like to use box method. So we have negative 2 and rad 2. And then that's being multiplied by negative 1 plus rad 2. All right, so we end up with 2, negative 2 rad 2, negative rad 2, and then the final one is 2. So this would end up with being on the top, we have 2 plus 2, which is 4, minus 3 rad 2, all over. And then on the bottom, it's nice and quick. We just do the outer one. So 2 times 2 is 4, minus 2, which is 2. We'll just put that here. All right, so now we divide and we end up with 2 minus 3 rad 2 over 2. See, it's a little bit nicer. All right, so now the equation of the tangent. So we need to do the same thing. We need to find our points. I have an unlimited amount of space. Why not do it over here? So we know r equals 2 plus sine 3 theta, and we know our theta is pi over 4. So let's first find out what our r is. Plus sine 3 pi over 4. And so this becomes 2, and then again, sine of 3 pi over 4 we know is rad 2 over 2. So we know what our r is and we know what our theta is. And so x equals r cosine theta. So 2 plus rad 2 over 2 cosine of pi over 4. And the nice thing here is our cosine of pi over 4 is going to be the same as the sine of pi over 4. So we can actually set these both equal. So we're going to end up with rad 2 plus 1/2, and that's our x. And so our y is going to be the same thing. All right, and I'm already regretting having this part of the problem. So we have y minus, and then the y coordinate, rad 2 plus 1/2. And then our slope, which is 2 minus 3 rad 2 over 2. And then I'm going to leave the rest for you. I am not going to keep simplifying this. This is good enough for me. There we go. I mean, yeah, we can distribute this and then distribute this and then FOIL all that out and then subtract each of these and get something a little bit nicer. But it's our equation of the tangent that we were looking for and asked for. I don't know why I wanted to know that, but there we go. So there's our slope. That's the main thing to find. And again, take this, plug everything in. So we have theta equals pi over 4. That is our tangent. It checks perfectly right there because that's our line that we found. So all that work tells us, yes, everything is correct. I've plugged it in here and it checks perfectly. So our slope works good. That's exactly what we got right here. You can plug that into your calculator with what we had and verify it. There you go. So the formula works great. So it's just r prime sine theta plus r cosine theta. So it's r prime, r, and it's sine, cosine, cosine, sine. Top is positive, bottom is a minus. And I always remember this as cosine selfish, so he gets the minus right after it. It works really well for a lot of things. So there you go.